Good morning to all. Welcome back to my channel. Today I am going to solve the introduction to machine learning week 10 assignment 10 questions which last date is 2nd April 2025. Guys, these are the credentials. Now we are going to solve the questions. You can see, guys, yes, 10 questions are there and we will try to solve the 10 questions. You can see, yes, 9 questions are there. There are 9 questions. Okay, so one by one try to attend the question. The first question is, pairwise distance between the 6 points is given below. Which of the following options shows the hierarchy of the cluster created by a single link clustering algorithms? Single link clustering algorithms. So both options are given. So also we have the answers. Now I'm going to put the answer here. This is option B, that is P3, P4, P5, P6, then P1 and P2. You can see I have mentioned the answer here, that is option B. Okay, P3, P4, P5, P6. P3, P4, P5, P6, P1 and P2. P1 and P2. From the above figure, we came to know that is a single link clustering, means also known as the nearest neighboring clustering. It merges the clusters based on the minimum distance between the 2 points of the clusters. Now we have to analyze these things step by step. So first, the initial structure, each point starts with a P1, that is P1, P2, P3 up to P6. Then find the smallest distance. If you find the smallest distance between the P3 and P4, so the distance equal to 1. Then merge them into the cluster, that is P3 and P4, P3 and P4. Then after updating the distance, we find that for a single link, the distance between the cluster and another point is the minimum distance between any points in the cluster and the other points. So what are the new distance? The new distance here, P3 and P4 to P1, that is equal to 8, minimum 8 and 9, we will consider as 8. And in case of P2, it is considered as 8 and minimum 6 and 7, that is P3 and P4 to P5, that is minimum is 6 and 7, we consider 6. And from P3 to P4 to P6, the minimum distance, that is 7 and 8, we consider 8. Now, next smallest distance between P5 and P6, that is distance to P5 and P6. You can see P5 and P6, that is called distance equal to 2. Then merging them into a cluster, that is P5 and P6. After that, you have to obtain the distance here, that is P5, P6 to P1, that is minimum is 5, 4, you consider as 5, and P5 and P6 to P2, that is minimum 10, 9, that we consider as 9, and P5, P6 to P3 and P4, that is minimum 6 and 7, that is 6. Next, smallest distance of this. Smallest distance between P1 and P2, that is distance cover is 3. So merging them into a cluster, that is P1 and P2. Now again update the distance, we find here minimum 8, 8, that is equal to 8, and minimum 4, 9 equal to 4. Next, smallest distance. The smallest distance between the P1 and P2, P1 and P2, P5 and P6. P1 and P2, P1 and P2, P1 and P2, P5 and P6. Okay. The smallest distance is 4. Merging them into a cluster, that is P1, P2, then P5 and P6. Okay, P1, P2, P5, 6. And again we have to obtain the distance, that is P1, P2, P5, P6 to P3 and P4. That is minimum 8 and 6, then equals to 6. Now finally, next to smallest distance, we have to merge this P1, P2, P3, P6, P3, P4 distance will be 6. Then you can see the step by step 1 to step 5. This is called the hierarchy of the merge. Okay, so the hierarchy of the clusters in order to point to the final clusters can be interpreted as a stacking of the earliest merged points. The first form, that is P3 and P4, followed by P5 and P6, then P1 and P2. Then the final order of the point is equal to what? It will be P3, P4, P5, P6, then P1, then P2, which is matches the B options. Okay, which matches the options B options. Now moving to the question number 2. Okay, 4 figures are there also. We have to analyze these things. For the pairwise distance matrix given in the previous questions, which of the following shows the hierarchy of the clusters created by the complex link clustering algorithm? Okay, shows the hierarchy of the cluster created by the complex link. Then again it will be option, we choose as option B. we choose as option B. You see that if we choose option B, that is option 2 means option B, that is P3, P4, P5, P6. We can see option B, P3, P4, P5, P6, then P1 and P2. This one, okay, this one. So you can see, guys, the completing link clustering uses the maximum distance between the points to the cluster to merge. So P3 and P4 distance is 1. After that, P5 and P6 distance is 2. Then merging P3 and P4, P5 and P6. That means this one and this one. We get from P3 minus P5 equals 6. P2 to P5, that is 6. Then what about the P1 and P2? P1 and P2 distance is 3 from separate clusters. So merging the cluster based on the maximum inter-cluster distance, we get P3, P4, P5, P6, P1 and P2. Okay. So correct option is 2, option B. Now moving to the question number 3. Question number 3, in which using the number of points n, sum of the points, that is sum, and sum of the square point, that is SS. You can determine the centroid and radius of the combination of the two clusters, means A and B. Okay. How do you determine the radius of the combined cluster? Radius of the combination, how can you determine in terms of n, sum and SS of both cluster A and B? How you can determine? Okay, radius of the cluster is given by this one. And note that we have the following definition of the radius by this before. Okay, radius is average distance from the number of points. And the basic formula is option C. Okay, option C, this one. Option C, 4. Okay, this is 3, option C. 3, option C. You can see radius equal to SSA plus SB by NA plus NB. Sum of A, sum of B by NA plus NB plus square. Okay, you can see the explanation part here. The formula combination of SS, sum of squares, SS means sum of squares and sum of both clusters normalized by their total points. Okay, N to NB. This matches the B's before definition. Radius average distance points to the new centroid to the merged cluster. That's why you choose the option C option. Option C. Okay, this one A, B, and C. Now moving to the question number 4. Moving to the question number 4. Statement 1. Two statements. Statement 1 are PO is robust to outliers. Statement 2 is because of multiple shrinkage, effect of the outliers is damaged. That is, statement 1 is true. Statement 1 is true. Statement 2 is true. Okay, but statement 2 is the correct region of statement 1. Statement 2 is this one is the correct region of statement 1. Okay, correct region of statement 1. This one is. So our correct option is option A, that is A. Your uses representing points and the shrinkage to reduce the outlier impact. Shrinking them as outliers by pulling them towards the cluster center, making the pure robust statement 2 extend statement 1. That's why I choose options 4, option A. Okay, guys, next move to the question number 5. Go to the question number 5. Terms K means on the input features of the data set using the following initialization. K means that is n cluster 10 and random state is equal to 6. Usually for the clustering tags we are not given label, but since we have labels for our data set, we can use our accuracy to determine how good is our clusters are. Label of the predictions classes for the points cluster and the majority true labels. Okay, A, B would be labeled as AAA. Then what is the accuracy of the label? Asking about what is the accuracy. For accuracy you can choose option B, 0.893. 0.8. Let's calculate how it will be 0.893. This is the correct answer, 0.893. Okay, this is the explanation. The minute data set consists of 70,110 digit image, that is 0 to 9. Okay, and with a 60,000 training sets and a 10,000 in the test set. Each with is 784, that is 2080 into 2080 pixels. K means is run with the K is equal to 10 clusters. It matches the 10 digits. Okay, or ensure reproducibility. K means clustering group 10 cluster based features simplicities. Okay, So in the ground truth table, we can evaluate the cluster by assigning the cluster majority to true labels and calculating the accuracy fraction correctly label points. So K means on min set typically achieve a good but not perfect cluster because digit like K is like a 4 and a 9 or 3 and 8 have the similar pixel patterns. This one, pixel pattern units to the sum is clustering. Claim is assume spherical clusters which may not perfectly align with the data distributions. So those studies and experiments that is using the split non K means upon the report accuracy that is around 0.85 to 0.90. When using the majority voting approach, if you choose, then among the options 0.89, it comes in between this. 0.89 is the most possible as it aligns the typical performance for K means with K equal to 10. Okay, that's why we choose option B, 5, option B, this one. Okay, 9. Then moving to the question number 6. Question number 6, this one. For the same cluster option, the previous questions calculated. This one, the RAND index, the formula for RAND index, this one. RAND index equal to A plus B by should be by combination of 2 and n, where A is the number of times per pair elements occurring in the same cluster in both sequence, and B is the number of times per pair elements occurring in a different cluster in the sequence. And here notice given two clusters are given by one ground truth table, another is prediction C using the clustering on the directed in question number 5, this ones. So choose that is 6, question number 6 option will be 0.919, okay, 0.919, this one. 6 option C, which will be here. Okay, the Randix measures similarity between the clusterings by considering the pair points. Here you can show A, B, and C number of pairs that are same cluster, both the grounds, truth, and predicted clusters. Number of pairs are different clusters for the ground, truth, and predicted clusters. The total number of pairs given by n by 2, that is equal to n equal to n plus n minus 1 by 2, where n is the number of points. So we have taken min set with the 70,000 points, that equal to 70,000 into 69,999 by 2, that is approximately 2.45 into 10 to the power 9. So from the question number 9, accuracy what you choose, which already choose 0.893, this one. Question number 5, 0.893, you choose this. 0.893. Okay, then the meaning that is 89.3 of the points are correctly labeled after assigning majority labels to the cluster. So the index is typically higher than accuracy because it accounts for both positive and negatives, including the pair of a correctly spread. So the given accuracy is 0.893. RAND index is of course significantly, that is 0.91 to 0.94, because it benefits from the adding of our two negative pairs. So among these options we choose 0.919 because this one 0.919. Option C, 6, option C, 91, the most reasonable as it reflects a high degree of agreement while being slightly above the accuracy. That's why we choose 6, option C. Now moving to the question number 7. This one. In RAND index can be viewed true positive. That means a pair of points belonging to the same cluster. Group of things. That is, another is B, that is true negative. Okay. So first a true positive and a true negative. Okay. A pair of points belongs to the different clusters. How then are the RAND index and accuracy from the previous two questions related? Okay. Not, that is 7 option G we choose, 7 option D, none of the above related. Then how it will be related? How it will be considered? How these things are related? The things are related, that is from question number 5 and 6. Accuracy is how much? Accuracy is 0.893. Remember, Rand index is 0.919. Now let's test the options. So if we take the two things, accuracy and rand, is they are not equal, because the first one accuracy is 0. The accuracy that is this one, accuracy is not equal to rand index. Here is equal to rand index is equal to 0.919. It's not equal to 0.893. Second thing, 1.1 into 0.893, this one, that is equal to 1.05374, which is not 0.919. Secondly, if you take a square, 0.896 square, that is equal to 0.79744, which is not 0.919. Okay, 0.919. So that's a choose none of the above. Rand index accuracy are related, but not so the similar linear quadratic relationship. It considers pairwise agreements, both true positive and true negative. Accuracy is pointage matrix, so the relationship between the data distributions and cluster size, which makes it complex, not directly proportional or exponential. The correct answer is none of the above. It's not related. Okay, 7 option D. Now moving to the question number 8. Run bridge on the input features of MNIST dataset using which n cluster, that is equal to 10, threshold is equal to 1. What is the rand index of 10? What is the rand index of 10? By calculating, we found 0.96 is the rand index of 10. See how the calculation is gone. Yeah, this one, correct answer is 0.96. 0.96 is well. Yes, this one, 8 option B, 0.96. Okay, so rand index achieved by which algorithms on the inside dataset with the given settings. Why we choose these options? Which is a hierarchical cluster among that the designed to scalable and efficient for the labs datasets. How it works? It works like the building tree-like structure called clustering features. Tree, CF tree. Recursively compress data points into smaller groups of called clustering features. CFs. Another thing is rand index is a metric used to access the similarity between two clusterings. It measures how the clusters is one clustering, predicted cluster, not cluster, another clusterings. Then bridge algorithm, which giving the parameters n cluster, that is equal to 10, threshold value 1. Here mentioned, okay, n clusters 10, threshold value 1. Threshold value 1 likely produced a clustering that is fairly similar to the ground truth table of the mentioned database. It's because the dataset is relatively simple and well defined, and the bridge algorithm is generally effective at clustering such data. Another is rand index of 0.9 indicates a high degree of similarity between the predicted clusters and the ground truth tables. Suggests that which algorithm is able to accurately group the data points to a meaningful cluster. So it is important to know that the exact rand index can vary slightly depending on the specific universe of this and the initialization is. However, 0.96 is a reasonable value for the rand index on the inst dataset of which is parameters. Okay, so that's why 0.96. 8 option B. Now move to the last questions here. Run the PC on the dataset input features with n components, that is equal to 2. Now the DB scan, using the DB scan ESP 0.5 with the minimum sample 5 on both the original features with a principal component analysis, that is PCA features, which are their respective numbers of outliers and noisy points detected by the DB scans. Okay, another option is an extra. You can plot a PCA features on a 2D plot using the matpolio.py plot scatter with the parameter c equal to yp, and where ypred is the cluster predictions to visualize the cluster outlines. Options we choose 9 option D would be the probable answer. You can see we have already calculated option 9 option D. You can see 9 option D. 1797, 1742, 1742. This one. Let me to explain. Mindset means dataset that equals 70,000 points. Here 784 features, that is original. After we say with n component, that is 2 the data is reduced to 2 dimensions. DP scan parameter, that is EPS equal to 0.5. Okay, and mean sample 5 single points from a cluster. Original feature is not 7, 8, 4 dimensions. High dimension, that is 7, 4 dimension. Distance between the two trades due to the cost of dimensionality with EPS equal to 0.5. Few points will have 5 or more neighbors with a small radius leading to the most points being classified as outliners. So the MNIST pixel values are typically normalized to 0 and 1. So the distance is 7 and 4D can be quite large. Euclidean distance between the 2 points, that is 784 to 28 square. Okay, that is, yeah, just a minute. The last one is yeah, last questions. Yeah, for the means pixel values, here you can see on these things. Okay, so for the MNIST, the pixel value is typically normalized 0 to 1, so the distance is 784D can be quite large. That is equivalent distance between the 2 points can be root over of 784 equal to 28. If all the features differ by and EPS equal to 0.5 is extremely small, so DB scan will mark most points as outlier. A reasonable estimate, that is null points closer to 73 would be outlier, but the option suggests a much smaller number, indicating the data might be pre-processed differently, okay, or scaled differently. Among the options, so 1797 outliers is the highest and most possible high dimensional data such as small text. The second is PCA features there is 2 dimension. After the PCA with the 2 components, the data projected into 2 spaces. The variance captured by the first 2 principal components of MNIST around 10 to 15%. So pointers spread out, but the distance are generally smaller than 784. With EPS 0.5, DB scan will still mark many points outlier because its densities may not be high enough for cluster with a small radius. Okay, it is slightly less than the original space between the reduced dimensionally compressed data. Number of outliers equal to D is executed slightly slower than 784D and 1742, slightly less than 1797. Make sense? So from the above, what we concluded that the pair, that is 1797 original pair and after 1742 PCA fits the expected behavior of DB scans with a small EPS value. With a small EPS value, where the high dimensional data results in more outliers and 2D data slightly fewer. Okay, that's why we choose these options. Now guys, you attempt all the questions. We are going to submit the answer. Okay, please wait, the assignment is submitted. Thank you for taking the week 10 assignment 10. Your answers are successfully submitted. We attend all the 10 questions you can see. Okay, the first question number 1 B, question number 2 also we choose B, question number 3 C, question number 4 A, question number 5 B, and question number 6 we choose option C, question number 7 option D, question number 8 option B, and question number 9 option D. Okay, so if you think that you get some knowledge, you can subscribe our channels and wait for the next video, that is we're going to produce the week 11 assignment 11 video very soon. And if you have any questions, you can put your questions in our comment box. We'll try to give the answer to the questions. Okay, till then prepare yourself, study hard guys, take care of yourself, goodbye.